Mathematics, Midterm Grade 11, Chapter 23, Constructions. Let's see objectives. By studying this lesson, you will be able to do constructions related to straight lines and angles, construct circles related to triangles, construct tangents to circles. Constructions related to straight lines and angles. First one, construction of the perpendicular bisector of a straight line segment. First, draw a straight line using a ruler, then mark 2 points and name them A and B. Now, keep the compass top of the point A. Draw the arcs from A by taking a length which is a little more than half the length of AB. Then, keep the compass top of the point B and draw the arcs from B as we did before. We'll see the intersection points. Mark them as C and D. Now, take the ruler and draw this straight line through the points C and D. The intersection point is X. Using a ruler, measure the lengths of AX and BX. I have got the same length, then AX equals XB. Using a protractor, measure the magnitudes of the angles AXC, BXC, AXD and BXD. I am getting all are 90 degrees. CD is the perpendicular bisector of AB. Second one, construction of an angle bisector. You have been given two intersected sides OA and OB. Take a length which is less than OA and OB onto the pair of compasses. Take O as the center, draw an arc such that it intersects both OA and OB. Name the 2 points of intersection of the arc with OA and OB as D and C. Taking a suitable length onto the pair of compasses and taking C and D as the centers, draw 2 arcs which intersect each other. Name the point of intersection of the 2 arcs as E. Join O and E. Now, measure the angle AOE and the angle EOB. You are getting same magnitudes. Then, angle AOE equals angle EOB. Then we can get OE is the angle bisector of AOB. Third one, construction of a perpendicular to a line through a given point on the line. We want to draw a perpendicular to AB through the point C which is on AB. Take a suitable length onto the pair of compasses and taking C as the center, draw 2 arcs that intersect the straight line segment AB on the 2 sides of C. Name the 2 points of intersection as P and Q. Taking P and Q as the centers and using a fixed radius, draw 2 arcs above or below the line AB such that they intersect each other. Name the point of intersection of the 2 arcs as R and join CR with a straight line. Then measure the angle ACR and angle BCR. You are getting angle ACR equals 90 degrees and angle BCR equals 90 degrees. So, CR is the perpendicular drawn to AB through C. Fourth one, construction of a perpendicular to a straight line segment from an external point. AB is a straight line segment and C is an external point. Take a length which is a little more than the distance from C to AB onto the pair of compasses. Taking C as the center, draw two arcs which intersect AB. Name the 2 points of intersection as D and E. Taking the same radius, draw two intersecting arcs taking D and E as the centers on the side of AB opposite to that on which C lies. Name the point of intersection of the two arcs as P. Join C and P. Name the point of intersection of CP and AB as Q. Now, measure the angle CQA and angle CQB. You are getting angle CQA equals 90 degrees and angle CQB equals 90 degrees. Then CP is the perpendicular drawn to AB from the point C. Let's see construction of circles related to triangles. First we discuss construction of the circumcircle of a triangle. First, draw a triangle ABC. Using the pair of compasses, draw the perpendicular bisectors of any two of the three sides AB, BC and CA of the triangle ABC. Can you recall your memory? How will you draw the perpendicular bisector? First, I'll draw the perpendicular bisector of AC. How will you draw the perpendicular bisector of AC? On the pair of compasses, take a length which is a little more than half the length of AC and taking A and C as the centers and the length on the pair of compasses as the radius, draw two arcs which intersect each other. Then connect them with a straight line. Now we can see a right angle here and both sides are equal. We'll draw the perpendicular bisector of BC. As we did before, we can draw the perpendicular bisector here. Then here we can see a right angle and both sides are equal. Name the point of intersection of these perpendicular bisectors as O. Taking O as the center and the distance from any vertex of the triangle to O as the radius, draw a circle. The circle passes through all the vertices of the triangle ABC. This circle is known as the circumcircle of the triangle ABC. The center of this circle is known as the circumcenter of the triangle. Let's see construction of the incircle of a triangle. First, draw a triangle and name it ABC. Using the pair of compasses, construct the angle bisectors of any two interior angles of the triangle ABC. I'll draw the angle bisector of the angle CAB. Using the pair of compasses, draw an arc with the center of A. Taking the intersection points of this arc and the sides of the triangle AC and AB as the centers, draw two intersecting arcs like this and draw the straight line. Then draw the angle bisector of the angle ABC. First draw an arc here as we did before. Draw two intersecting arcs here and draw the straight line. Name the point at which the angle bisectors meet as X. Then construct a perpendicular from X to any one of the three sides of the triangle. I'll construct a perpendicular from X to AB. Draw two arcs on AB from X. Next, taking these arcs as the center, draw two intersecting arcs below the line AB. Then draw the straight line like this. Now you can see a right angle here and name the foot of the perpendicular as P. Taking XP as the radius and X as the center, draw a circle. We can see that circle which was constructed touches the three sides AB, BC and CA internally. Therefore, it is called the incircle of the triangle ABC. The center of this circle is known as the incenter of the triangle. Let's see construction of the excircle of a triangle. Draw a triangle and name it ABC. Then produce the side AC to E and AB to D. Then, using the pair of compasses, construct the angle bisectors of the angles angle CBD and angle BCE. First, I'll draw the angle bisector of the angle CBD. Draw an arc here and draw two intersecting arcs. Now, draw the straight line. Then, I'll draw the angle bisector of the angle BCE. Draw an arc here and draw two intersecting arcs. Draw the straight line. Name the point of intersection of the two bisectors as P. Construct a perpendicular from P to BC. Draw the arcs on BC and again draw two intersecting arcs here and draw the straight line. Name the foot of the perpendicular as Q. Taking P as the center, draw the circle with radius PQ. The circle touches the side BC and the sides AC and AB produced externally. Therefore, it is named the excircle of the triangle ABC. Its center is known as the excenter of the triangle. Exercise 23.2, question number 4. First one, construct the triangle ABC where AB equals 7 cm, BC equals 6 cm and AC equals 5.5 cm. Second one, Construct the angle bisectors of the angles angle ABC and angle BAC. Third one, name the point of intersection of the two angle bisectors as P. Fourth one, draw the incircle of the triangle ABC. First question, construct the triangle ABC where AB equals 7 cm, BC equals 6 cm and AC equals 5.5 cm. Very first draw a straight line using the ruler. Then measure 7 cm and draw the arcs here A and B. It should be 7 cm. Then it's given BC equals 6 cm. Measure 6 cm using the compass and keep on top of the point B and draw an arc here. AC equals 5.5 cm. Then measure 5.5 cm using the compass and keep on top of the point A. Again draw an arc here. Connect these points with the ruler. This intersection point is C. Here 6 cm and this length is 5.5 cm. Next question, construct the angle bisectors of the angles angle ABC and angle BAC. First take this angle, draw the angle bisector and draw the straight line. Now take this angle, draw two intersecting arcs and draw the straight line. These are the angle bisectors of the angles angle BAC and angle ABC. Next question, name the point of intersection of the two angle bisectors as P. Then draw the incircle of the triangle ABC. We have drawn the angle bisectors here. Then so what is the center? The center is P. We don't know what is the radius. Then construct a perpendicular from P to AB to find radius. Draw two arcs here. Again draw two intersecting arcs and draw this straight line here 90 degrees. Then what is the length of radius? We can take this length as the radius. Now keep on top of the point P and you can draw this circle. Exercise 23.2, question number 7. Construct the parallelogram ABCD where AB equals 6.2 cm and angle ABC equals 120 degrees and BC equals 4.5 cm. Second one, produce the sides AB and AC and draw an X circle of the triangle ABC. Third one, measure and write down the radius of this circle. First question, construct the parallelogram ABCD where AB equals 6.2 cm, angle ABC equals 120 degrees and BC equals 4.5 cm. Very first draw a straight line. Measure 6.2 cm using the compass and draw the arcs here A and B. It should be 6.2 cm. Then it's given angle ABC equals 120 degrees. Then draw an arc here, mark 60 degrees, again mark 60 degrees. Connect the this intersection point with B, then here 120 degrees, measure 4.5 centimeters using the compass and keep on top of the point B and draw an arc here. Then this intersection point is C. Now you can complete the parallelogram ABCD. Which method should you follow to draw the parallelogram ABCD? You can follow the method that the length of opposite sides are equal. Then take the length of AB using the compass and keep on top of the point C and draw an arc here. Then measure the length of BC using the compass and keep on top of the point A and again draw an arc here. This intersection point is D. Now connect A to D and D to C. AB is parallel to CD and BC is parallel to AD. Now you can see the parallelogram ABCD. Next one, produce the sides AB and AC and draw an X-circle of the triangle ABC. How will you draw an X-circle of the triangle ABC? By taking the angle bisectors of exterior angles of the triangle ABC. First, produce the side AB. I have already produced the side AB. Then take this angle and draw the angle bisector. Now connect A to C. Now you can see the triangle ABC. Take the exterior angle and draw the angle bisector here. Then this intersection point is O. Then we should take the radius. First, construct a perpendicular from O to AB to intersecting arcs and draw the straight line. This length should be taken as the radius and keep on top of the point O. Then you can draw this circle. Measure and write down the radius of this circle. You can measure it. I am getting radius equals 2.1 centimeters. Let's see construction of a tangent to a circle. What did you know about tangent? The straight line drawn through a point on a circle and perpendicular to the radius through the point of contact is a tangent to the circle, as well as the tangents drawn to a circle from an external point are equal in length. We'll consider how to construct tangents to circle using these theorems. First, we discuss construction of a tangent to a circle through a point on the circle. Our theorem is the straight line drawn through a point on a circle and perpendicular to the radius through the point of contact is a tangent to the circle. Then draw a circle. The center is O and X is a point on it. Then draw the line OX and produce it. Mark P somewhere. Using the pair of compasses, construct a perpendicular to OP through X. Draw the arcs and I am drawing a perpendicular. Draw the straight line. Then The intersection point is X and name that perpendicular as RQ. RQ is the tangent drawn to the circle through X. Let's see construction of a tangent to a circle from an external point. I'll use the theorem the tangents drawn to a circle from an external point are equal in length. You have been given a circle. O is the center of the circle and A is an external point to the circle. Join OA. Construct the perpendicular bisector of the straight line segment OA. I'm drawing the perpendicular bisector of OA. Name the point of intersection of OA and its perpendicular bisector as B. Then, taking B as the center and ABO, BO as the radius, draw two arcs which intersect the circle. Name the 2 points of intersection as Q and P. Draw the lines AP and AQ. Did you see? AO is the angle bisector of the angle APQ, as well as AB equals BO and AP equals AQ, as well as the angle APO equals 90 degrees, angle AQO equals 90 degrees. You can measure the angles using the protractor and you can measure the length of the side using the ruler. Then we can get AP and AQ are the tangents drawn to the circle with center O from the point A. Exercise 23.3, question number 5. First one, construct the triangle ABC such that AB equals 5 centimeters, AC equals 3 centimeters and angle BAC equals 90 degrees. Second one, construct the circumcircle of ABC. Third question, construct a tangent to the circle through the point A. Fourth one, name the point of intersection of the tangent drawn through A and BC produced as P. Fifth one, construct another tangent to the circle from the point P. First question, construct the triangle ABC such that AB equals 5 centimeters. Very first, draw the straight line and measure 5 centimeters using the compass and mark the arcs here A and B. It should be 5 centimeters. Then it's given angle BAC equals 90 degrees. Then draw an angle which is 90 degrees here. Next, measure 5 centimeters using the compass and keep on top of the point A and mark the arc here. This intersection point is C and it should be 3 centimeters. Now connect B and C. Now you can see the triangle ABC. Next one, construct the circumcircle of ABC. How will you draw the circumcircle of the triangle ABC? You can get that by constructing the perpendicular bisector, but this is a right angle triangle. So we can follow this method to construct circumcircle of triangle ABC. This method is very easy. First, draw the perpendicular bisector of AB. Then what is the BC? BC is the hypotenuse of this triangle. Then we can take the intersection point of hypotenuse and perpendicular bisector of AB as the center. Then we can take OB or OA or OC as the radius. Now we can draw the circle. Next one, construct a tangent to the circle through the point A. First connect O and A. Now draw a perpendicular to AO through the point A. This is a tangent to the circle through the point A. Next one, name the point of intersection of the tangent drawn through A and BC produced as P. I have already produced BC, then this intersection point is P. Next one, construct another tangent to the circle from the point P. We know the theory that the tangents drawn to a circle from an external point are equal in length. Then take the length of PA using the compass and keep on top of the point P and mark another arc on the circle like this. Now connect this intersection point and P. This is another tangent to the circle from the point P. Exercise 23.3, question number 6. Construct a triangle KLM such that KL equals 9 centimeters, angle KLM equals 90 degrees and LM equals 4 centimeters. Second one, construct the angle bisector of angle KLM. Name the point where E meets KL as O. Third one, construct a circle taking O as the center and OL as the radius. Fourth one, mark a point T on KM such that ML equals MT. Fifth one, find the magnitude of angle OTM. Sixth one, draw another tangent to the circle from the point K. First question is construct a triangle KLM such that KL equals 9 centimeters, angle KLM equals 90 degrees and LM equals 4 centimeters. First, draw a straight line using the ruler and measure 9 centimeters and draw the points K and L using the compass. It should be 9 centimeters. Then it's given angle KLM equals 90 degrees. Then draw an angle here which is 90 degrees. Measure 4 centimeters using the compass and mark the arc here. The intersection point is M. Now connect M and K. Now you can see the triangle KLM. Next one, construct the angle bisector of KML. Draw an arc here, then draw two intersecting arcs and draw this straight line. Name the point where it meets KL as O. This is the point of O. Construct a circle taking O as the center and OL as the radius. Now, what is the center? The center is O. Then, take the compass and keep on top of the point of O and take the radius and draw this circle. Next one, Mark a point T on KM such that ML equals MT. Take the length of ML using the compass and keep on top of the point M and mark that length on KM. Find the magnitude of angle OTM. First connect O and T. Then you can measure the angle using the protractor. I am getting angle OTM equals 90 degrees. Next, draw another tangent to the circle from the point K. Angle OTM equals 90 degrees. As a result of this, KT is a tangent to the circle. Then we know the theory. The tangents drawn to a circle from an external point are equal in length. Then take the length KT and keep on top of the point K and draw an arc on circle. Then connect that intersection point with K. This is another tangent to this circle. Grade 11 Mathematics Part 3. Now you can do these exercises. Thank you everyone.